After months of hard work, late nights, and countless study sessions, students have finally completed their first semester of exams and are able to peacefully enjoy their time off school in their purple-dyed leather jackets. That is until the crowd-marked grades are released and second semester tuition fees are posted on Solus. At which point, certain students are faced with the choice of continuing their studies or enrolling in J section, thereby allowing them to solidify their understanding of fundamental concepts in a 6-week-long extended term. For those who do decide to pursue this option, there is no shame in J section, as J does stand for genius. However, you'll want to see my previous video on Speed 1.5 for an accurate overview. Feel free to leave a like while you're there. I can wait. Once that is complete, as per good engineering practice, it is essential to establish the problem scope and deliverables of a given project, along with a timeline of key milestones as shown in the following Gantt chart. Now, if the words Mod 1 don't immediately trigger intense feelings of anger and severe anxiety, you're in luck, because Mod 3 involves another group-based design project that lasts the entirety of the second term. The major difference between it and Mod 1 being that the stakes are considerably higher than just your grades and mental stability, as you are working for a client to develop a concrete solution to a real-world problem. Considering this, several students apply themselves much more than Mod 1 to develop an intricate and carefully designed solution, which is rapidly shattered when they realize just how far the university budget will bring them. As the saying goes, you'll never pass 112. Similarly to how the direction of an induced EMF will never favor the change in magnetic flux that caused it, or how the direction of a magnetic field from a current-carrying wire will never stray from the Biot-Savart law. But you'll never understand what any of that means because you'll never pass Frosh. Much like its prerequisite course, 132 expands upon concepts of high school chemistry to establish a solid foundation for those pursuing the chemical engineering and engineering chemistry disciplines. It serves to all students as a justification for selecting engineering over biology degree, as the required memorization of organic compounds is the second worst thing in existence. That is, after filling out a 15-page ITP metric survey. 162 is a series of weekly labs where students use AutoCAD software to create various parts and assemblies on a computer, as well as drawing isometric, orthographic, and auxiliary views that ultimately make you question if you're actually pursuing an art side degree. Despite the nuisance of having to draw straight lines without a ruler, the course provides fundamental knowledge of the manufacturing process, which is essential for those enrolling in the mechanical engineering discipline. The real upside to this course is that it solely consists of a lab, meaning that the 3-hour weekly time commitment is quite nice. Wait, there are lectures for this course? Fuck. 172 is a continuation of 171, which covers 3-dimensional vectors and surfaces, power series, and multivariable integration. For a university class, it has a strong emphasis on bugs walking on paraboloid surfaces and the cross-sectional area of sliced potatoes. The real downside to this course is that you'll never be able to look at a plate of spaghetti the same way again. Absolutely terrifying. At this point in the video, it is essential to review the Gantt chart to ensure that everything is on track. And while it is visibly apparent that things are dramatically behind schedule, it is no reason for concern, as the project's deliverable can easily be modified to reflect what we are currently able to produce. Perfect. 174 is an introduction to linear algebra that redefines students' understanding of mathematics and is a key prerequisite course for the Apple Math discipline. Students are brought to challenge their fundamental knowledge of math, where the most trivial of operations are questioned. In a sense, the contents of the course serve to some students as a mathematical revelation, as its applications can span to operations of higher dimensions. One of the biggest words of advice before familiarizing yourself with defining real vector spaces is to familiarize yourself with navigating the two following YouTube channels. Finally, 182 is an introduction to mechanics, which is the fundamental prerequisite course for civil engineering. It covers a wide range of topics that are essential considerations in any modern infrastructure project, being static equilibrium, bending and shear forces, truss deflection under an applied load, and more. It has long been a kept secret within the faculty that the course was solely introduced to allow students to visually assess a structure's stability in a moment's notice, thereby preventing them from putting themselves in potentially dangerous situations. To conclude any engineering project, it is crucial to review that the deliverable solves the given problem. While this video allows Frosh to have their disappointment met with adequate expectation by providing them with an overview of their winter term courses, it fails to prepare them for the inevitable letdown of their subsequent academic years and disappointment of life in general.